really long beaches, right? This is a strand system or whatever, but it's a really long beach. This is part of the longest barrier island system. We're going to talk about barrier islands today. This is one of the longest, or if not the longest, barrier island system in the world. So it goes all the way from Boulevard Peninsula on the other side of Galveston Island, all the way down into Mexico, about another 100 kilometers into Mexico. So this is the longest barrier island kind of beach system in the world. There's a reason for that. The reason is that this is a wave-dominated system. All right, so it's a micro-tidal system. So it's got micro, macro, meso tidals. Anyway, really small tides, like a meter, meter and a half at most. And so what that means is that waves take over, and so the dominant force, the dominant bit of energy that we will see here, now moving grains around, are waves. Right? And when we're talking about waves, we're talking about longshore drift. Right? Because waves come in at an angle, and then they move sand down the way. So they distribute sand all along this nice big old long beach system that we'll see. So the beach here looks kind of like the beach at Boulevard Peninsula, which kind of looks like the beach on Matagorda Island, which kind of looks like the beach at Mustang Island, which kind of looks like the beach at North Padre, pretty much like South Padre, and you know, so they all look about the same because all these conditions are about the same. All right.
What are some examples?
We bulldoze this beach a lot and clean it up and do lots of different things to it to make it nice for us to come down here and picnic and vacation. So it is not quite a natural beach system, right? And we'll see that through everything that we've seen today, is that we'll be talking about the natural processes, but then we also have to say, yeah, but we're trying to make it static and do things to it, and so we're modifying it, but then the natural processes take over again, so let's see what happens there, right? But down here, we're getting kind of close to the natural processes, right? The natural thing. So, way offshore, so if you look offshore, past the breakers, past everything, that's out there, right? So that's going to be far offshore, you know, a kilometer or whatever, something like that. So you get into the area where there's the waves. It's all wave action still, and so hopefully you guys remember back with all the orbitals that go down in the circles, and the bigger the waves, and the deeper the water it can get. So we're out there at like mean, mean fair weather wave base and storm wave base. You know, when the bigger the storms, the hurricanes come through, they can affect the bottom of the water, the bottom of the seafloor, and stir things up a little bit deeper out there. But today we're seeing like just natural waves. This is fair weather kind of stuff, right? So way out there, the energy is very low, right? Because particularly on the seafloor, because it's not very big waves, and so the waves are just, you know, kind of sloshing things if they can't touch it. Not a lot of energy, can't move as big of grains, right? So that we'll see that theme today too. I like to talk about sedimentology with three parameters. What are those three parameters, Emery? Energy. So one of them is energy of the system. The bigger the energy, the bigger the grains it can move. That's a real simple concept, right? So that's you know, sedimentologists, we can get way into the minute details, but for us, just for today, the bigger the energy, just think about the grains you can move, right? So out there, very low energy, you can only move a little bit of grains. When the storms come through, that's when you get hummocky, cross stratification, all sorts of stuff. We will not see that today. Go to another field trip. All right. As we come along, then you start seeing in the offshore transition, you can see that. But now we're seeing a little bit where the waves and the breakers start going on. You see the surf zone, you see the waves coming up. That's when it's really affecting the bottom. That's when those orbitals are all touching and the waves fall over and break, right? And so you can kind of see as they're going up to there, the breaker area right there in the surf zone is pretty close in, not that far. But it's also, so that's the area where you call the shore face, where there's always water over top of it. Right? So that's the shore face. Then you come up into the swash zone, and that's where the waves come back and forth, where it's just mostly covered by water and nothing. This is where you're getting more energy. So when you get more energy, you can move more grains, right? And so the highest energy we can, for those of us who have sandals on, because I love doing this field trip, because I can do a field trip with sandals, so it's awesome. But you can go out there and you can actually see in the water where the grains can move back and forth, and you see a little bit of the finer grains, the silts and the muds, they come in, and so you can see what they settle out, and so you can actually see the different grains And then behind it, you have the dunes and the back barrier world. We are kind of mimicking the dunes here by bulldozing it. You can see that these dunes here are not real. Why can we see that the dunes are not real? What normally energy is moving the dunes around? Wind. So that's the other type of energy we have here. So we've talked about wave energy, we've talked about tides, and we've talked about wind. Those are the three forms of energy that can move grains around here on the coastal environment. Here, I'm pretty sure the wind did not move that log up on top, right? So that was bulldozed up, and we're kind of mimicking the dune field, so we kind of have it here. But you can see, even amongst that, and as we drive along, you can see that the wind is still active, it's still moving grains along, and so it modifies the piles that we build up. So you can still see the wind ripples and things. And as we go along on the full tile in the back, you can look and see that's up. What? Oh yeah, some wind ripples over there, and the wrapping around through there. So you can see, so the wind is modifying that bulldozed bit of pile. So all the natural processes are going on, we're just kind of modifying it as we go along to fit our own needs, which is fine, it's okay. The next page, on page 14, you can see this nice vertical profile, right, of a shore face sequence. We are going to see a lot of the aerial extent of that because that's what we can see. So the more horizontal, we don't get a lot of vertical connection here in these modern day systems. We're doing a couple of push boards, well, the students will, and you know, to see some things and see a little bit of grain size variation, that sort of stuff. But this is the classic, shore face profile. This coarsening up and thickening upward sequence as we go from offshore to the beach. Now, why do we get this coarsening and thickening upward sequence? What does that signify? Well, some sort of propagation, yes, but what energy is going on down here? Very low energy down here, and we're getting high energy through here. So that is why we're going from low energy, we're going from muds and silts up into sands, is because we're changing, we're all prograding. The shoreline is prograding over, so the shoreline is marching out in a vertical succession down below. You're going to get mud, and then it goes up into the sands. That's why, because we are changing the energy of the system. The energy of the system can move bigger grains, and so if those grains are available, it does. And then we're not going to see them here, but you can describe all this stuff in core and in outcrops because it's got lots of sedimentary structures and other lines of evidence to show the energy of the system going on from there. But the big one is grain size. Just for pure grain size, you can already get an idea of, am I in a higher energy environment or I'm in a lower energy environment. All right? So, look at that. Somebody take a look at it.
You know you're a nerd when you have that.
Yes, exactly. Well, you know you're a nerd when you carry this around with you in your car.
That I don't do.
I actually have grain-sized cars and cam lenses everywhere. So who can describe this grain for the sand for me? Just call out. What are some of the things that we need to know?
Well-rounded.
Well-rounded. All right, that's interesting. Well-rounded. What size is this? What size would you call this? I've heard medium. I've heard fine. Very fine. Something with the hand lenses. What are you thinking? Look at that. Somebody take a look at it.
You know you're a nerd when you have that.
Yes, exactly. Well, you know you're a nerd when you carry this around with you in your car.
That I don't do.
I actually have grain-sized cars and cam lenses everywhere. So who can describe this grain for the sand for me? Just call out. What are some of the things that we need to know?
Well-rounded.
Well-rounded. All right, that's interesting. Well-rounded. What size is this? What size would you call this? I've heard medium. I've heard fine. Very fine. Something with the hand lenses. What are you thinking? Introduced to what I'm talking about right here in the wave actions and the wind and the storms that are coming through. Those processes are pretty standard. They come through here, things happen, and then so it hasn't changed shoreline used to be right behind us back in the 50s. This program in 1995, we operated out to where we could actually stand on vegetation, right? And then from that point, you can see that the 1995 shoreline is black, and we've stepped back, and so the shoreline has been kind of static, but it's been slowly coming back since the 90s, right? So we are retreating. The shoreline generally around Texas coast is retreating because we have a little bit of extra sea level rise, and so that will affect. So topography has something to do with that. But then the other thing is, what's the other controlling factor? One of the other controlling factors?
Subsidence.
Well, that's topography. So topography, there's a little bit of substance going on, but the sea level is going back because we are right. The shoreline is moving back because we're starting to sea level rise in general overall is coming up. But then also, what's the other? We said energy,
Sediment supply.
sediment supply. So we're mucking up sediment supply. All right, cool. We'll talk about that because what are we doing? Sediments are coming from that way. What are we doing way up there?
Jetties.
Well, we got jetties. We're dredging the boulevard roads in between the boulevard peninsula. We're trying to capture it all for the Galveston beaches, and so we're really mucking up sediment supply a little bit as well. So that's another reason we're not replenishing. The natural replenishment of the sand is not allowing it to at least staying in place, so we're losing it a little bit, right? And it's moving backwards. Now the other feature that you see here as we go along is, as we're going on from here, all right, okay, we're slowly retreating, shoreline's retreating a little bit, but then, oh wait a minute, we just had Hurricane Claudette came through, Tropical Storm Grace came through, and then, oh, we got some, oh, the whitest sand, that came through. Oh, we got a breach that goes in putting sand in the back barrier world. We got that thing is kind of long-lived. Oh, then Hurricane Ike comes through, breaks through the dune field again, and that beach, that shoreline profile kind of goes, it hangs out through there, and then, oh, vegetation comes back in, and now, well, then we bulldozed it closed, and so so we actually really modified it. So you can see that there's something that we call wash-over deposits, right? And so when that storm surge comes in, it's bringing a wall of water with the highest energy. So in the highest energy, that means it can move the largest grain sizes. And what's the largest grain size that we see on the beach here today? Somebody mentioned it already. Well, that's the sand grain, but what's the largest grain size that we see?
Shell?
Yeah, we got shells. I mean, that's still a grain. I mean, it's a class, right? It's not living anymore. It is now a class. See, sedimentologists, we look at everything as like, if it's not living, it's a class that's just moving around. Right?
Mud balls.
Yeah, and you actually have some mud balls out here too, yeah, which are really big, right? And so that's the largest grain size that we have in this system is these shells and sometimes these mud balls going on, which are kind of interesting. So they move around in the system, so there has to be energy at least every once in a while to move that grain size. Right now, just at the surf, you know, you might not actually be able to move even these bigger shells, right? But when the tide is high and when you get a little bit extra wind, then you can start moving these things periodically just in a smaller environment. But when a hurricane comes through, man, you can move everything, and it's not that you can actually move larger grain sizes. Now you can move, you know, cars and other things and stuff, you know, if it's big enough, the surge is big enough. But then also you can move the quantity of material that you can move is increased as well. So throw out some terms, that's what sedimentologists call competence, how big of a grain size it can move, and capacity. It can move a lot of material. So when a hurricane comes through, it's got this big old wall coming up, it hits against the dunes, right? And if it finds a little bit of a spot, a little bit of low spots, that sometimes now we nicely introduce by our roads to get onto the beach, it will push all the water through there. And so when it pushes water through there, it carries all the beach sand and everything else. And then as it gets into the back barrier world, after it kind of comes together, so the flow lines come together, things speed up even higher energy. And then when it gets into the back world, it spreads out, it slows down, and then deposits. So these are wash over deposits. You are washing material from the beach over the dunes and into the back barrier world. So we'll see that a lot today in these wash over deposits, because we are in a wave dominated system that is periodically interrupted by lots of hurricanes. Now, the other thing you can do is, one trick we can do in there is you can rub your fingers together, and if you feel grains, that means it's at least fine grain sands. You actually have sand content. If you can't feel any grains, then it's silts and clays. That's all you can do. Now, if you want to tell if it's silts, then you eat a little bit of it. And your teeth are a little bit more sensitive, and your teeth can feel silt grains. But if you can't feel silt grains, then it's all mud. So even if you don't have a grain size card, you can tell basically what the grain size is. So, yeah, so these mud balls, they come from, low energy environments, right? Because all the environment, all they can do is just move this grain size.
How do they get out here?
But then they get deposited somewhere, but then a storm, or we muck it up or something, or they can get eroded into, and we actually see a little bit of an outcrop down there. We'll see this material, right? And so it comes off, right?
Maybe getting dredged out there.
It could be too. It could be dredging it up as well. But mud includes some darkers and some whites, right? And we also see them preferentially placed in a particular location on the swash zone as we're coming back and forth, right? Or if you put there, it's all related. So the dark stuff is probable heavies. Organics are a little bit lighter. What's the white stuff?
That's the clean.
Right there. Speak up, Mark. Yeah, it's broken up shells. It's broken up shells, right? So they're a little bit bigger, and they're slightly different density than the quartz, right? Because they're carbonate material. I can't carry the carbonate anymore, but I can still carry my silts and other things and move it on. So the preferentially dropping out in this very micro energy world. And you see that in outcrop, you see that off the hospital. Right? They really help you out.
So should the colors on each side change depending on if it's low tide going in and out, because if you dropping earlier going out?
This is the last one, so this is the stuff that's going out.
Right.
But yeah, but it's going to move around depending upon like that. We'll talk about when we get down to the Brazos River. We'll be able to see how ripples are really working through there. It's a little there, but you can still see it out through here. And don't get me started on ripples. There's people go full hog on ripples, and they put way too much stock in them. But ripples are kind of fun. Where this is coming in, right? There's not much stuff. So it's where the energy, where the waves is right there, where the waves are just getting that last little white cap going on and hitting it, and you can actually walk out there and you can see all the stuff, including sand. So that is the highest energy in normal setting, or and mostly as you're coming on through here. So that highest energy had to be up there to move that grain size. And so it can move those grain sizes and push it up to there, but then as it was going back, it's like I can't grab it again and move it back, so that's where it is. And so you will see this line, and you can actually kind of see it a little bit. We clean it up, so it's kind of hard to see. But there's got to, at the top of the berm, because it's got to push it way up, and if it got over it, it's going to, gravity's going to take off a little bit and help it out. But then at the top of the berm, that's where you get the kind of your seaweed and all your logs and everything else when the last big waves actually comes in. That's what's called a rack line. WRACK. So that's kind of like that line of seaweed and other flotsam and jetsam and stuff that you see on the beach. And that's actually going to become important, maybe when we go to Galveston Island, because that actually has that can play a role in the format.
Big storm event.
It's more
not normal high tide.
Use the term dominant. Because it can change. It can actually go from west to east, because it's depending upon the storms. It depends on where the waves are going on. And so there is a source for those just a couple kilometers down that way. And so it could possibly have come from that. That's kind of where I expected it would come from, when longshore drift was actually moving this way, because every once in a while it goes that way. And we know that because we've got John Anderson and Julie Wellner and lots of people from Rice and U of H have gone and done piston cores out there, and they can document the mud that's coming out of the Brazos River, where it went. So we know that longshore drift moves back and forth. Dominantly, it's all moving this way, but every once in a while, yeah, locally you can get some little things happening. Lots of things going on here, right? You're already learning enough to bore your families to tears just in this first 30 minutes. Awesome. All right. Well, at least you'll be able to get them to the beach. You gotta you know, a little bait and switch. Bring them to the beach and then have the science lesson at the beach.
We're going to the beach for Thanksgiving.
There you go. All right.
Port
So,
Aransas still does.
so if you haven't, go out there in the surf zone itself, and you can actually watch sand grains move around. It's kind of cool. At least I think it's cool. So
The chance of actually preserving some of these trees